Okay, so finishing up question number 26 on page 191. We were at this point where we had done the sum of the forces in the y and found Fn. We did sum of forces in the x, max was 0. So we found mg sine theta was equal to mu mg cos theta. The mg's will cancel, so we'll be left with sine equals mu cos theta. We're trying to solve for mu, so divide both sides by cos theta, and you'll get sine theta over cos theta. You know what theta is, so you could fill it in here, but I want to show you something neat, because sine theta over cos theta is equal to something, and it'll be handy in your life if you know what. We know sine is equal to opposite over hypotenuse, and you know cos is equal to adjacent over hypotenuse. So if you divide opposite over hypotenuse by adjacent over hypotenuse, dividing by a fraction is like flipping and multiplying, so it becomes opposite over hypotenuse times hypotenuse over adjacent. The hypotenuses cancel, and you're left with opposite over adjacent, which is tan. Sine theta over cos theta is tan theta. So to find mu, you just have to do the tan of 3.5. And when you do, you get mu to be 0.06116. Okay? And that's it for number 24. So now to turn the page over, you had two others, 25 and 26. That was number 26, and you had two others, 27 and 28, over on page 194. So number 27 says you flick a 5.5 kilogram gram coin up a smooth board propped at an angle of 25 degrees. If the initial velocity of the coin, so it's going this way, so VI is 2.3 meters per second, and it means, because they say you flick, it means the force isn't on it anymore, right? You've given it an initial velocity and you've stopped pushing it. Tells you the coefficient of friction is 0.4. How far does the coin go up the board? Okay, so you have your initial velocity, you're looking for your delta D. In other words, how far does it go up before it stops? So VF will be 0. But you need to find A. So FG is going to be acting straight down. So this will be FGY. FGX will be down the incline. They gave us a coefficient of friction. Whoops, it's moving up the incline. So friction will be acting down the incline. And this is Fn. Okay, so you want to find A. So the first step would be to find Fn. So sum of the forces in the y direction is equal to MAY, which will be 0. So Fn minus Fgy equals 0. So Fn will equal Fgy. Look at this triangle. This is 25. It's the adjacent side, so it should be Fg cos theta. So Fn will equal mg cos theta. They gave us an m, so you could find it, but don't do it. It's going to be messy. 5.5 grams. You'd have to change it to kilograms. And then, yuck, don't do it. Leave your letters. In the x direction, there are two forces, Fgx and friction, but they're both acting down the incline, even though the coin is moving up the incline. So it's going to be minus Fgx minus friction is equal to max. Once you flick it, there's no force going up the incline. Fgx is the opposite side, so it should be Fg sine theta. Friction, of course, is mu Fn. And you're looking for the A, so you're going to divide by the m. So it'll be negative mg sine theta minus mu, and in place of Fn, you can fill in mg cos theta. What's going to happen with your m's again? They are going to cancel, which is why you should not have filled in your numbers. So AX will equal negative 9.81 meters per second squared sine of 40? No, 25 degrees minus, forget what the mu was, that was the 40, 0.4 times 9.81 meters per second squared cos of 25. And when you do this, you should get an AX of negative 7.702 meters per second squared. Okay, that's not the final answer. The question wanted to know how far up does it go. You now have an A, a VF, a VI. VF squared is equal to VI squared plus 2A delta D. So delta D is equal to VF squared minus VI squared over 2A. VF is 0, so negative brackets 2.3 meters per second squared over 2 times negative 7.702 meters per second squared. The two negatives will cancel each other out. You should end up with a delta D of 0.3434 meters. Okay? Number 28. Has an inclined plane in it. Imagine. In a box. You were pushing a 53 kilogram crate, so you're pushing it up the incline. So this time you have an F going this way. At a constant velocity, that means AX is going to be 0, right? Constant velocity. The ramp makes an angle of 22 degrees. The force you're pushing with is 373 newtons. With what is the coefficient of friction? What is mu? So FG is acting straight down, FGY into the incline, FGX down the incline, Fn up the incline, and if it's straight up into the air, and if it's moving up the incline, friction will be acting down. Okay, so start again. Sum of the forces in the y should be equal to MAY, goes to 0. So Fn minus Fgy should be equal to 0. So Fn should be equal to Fgy, which should be Fg adjacent side cos theta. So Fn is equal to mg cos theta. Again, I would wait on filling my numbers in, and I would go to sum of the forces in the x direction. In the x direction, we have F going up the incline, we have friction going down the incline, we also have Fgx going down the incline, so they're both negative, and it's at constant speed, so Max is 0. You don't know F, so take the other two terms over. Friction will be mu Fn plus Fgx is Fg sine theta. So F will equal mu Fn is mg cos theta plus mg sine theta. And now fill in your numbers. It told, oh no, we're trying to find the mu. Sorry, rearranged for the wrong thing. So bring this back over here. So F minus mg sine theta will equal mu mg cos theta. Sorry about that. I thought we were solving for F. That's where I need you in front of me and not at home. F minus mg sine theta, and then you're going to divide by mg cos theta. Can you cancel out the mg's? Please say no. So mu is equal to 373 newtons minus 53 kilograms times 9.81 meters per second squared sine of 22 divided by 53 kilograms, 9.81 meters per second squared cos of 22. Carefully, slowly type this into your calculator, and you should get 0.3697 for your coefficient. Congratulations, your first set of inclined plane questions are done.